to resistivity times length over A. Okay, so the resistance, the R, is measured in units of ohms, which the Greek symbol is the capital omega. Okay, and then the resistance of a resistivity, this is one of the formulas here, is equal to the rho here is resistivity. The length here is meters, of course, and then the area is meter square. Now, in terms of units, in order for us to work this out, if this is in meters and this is meter square, what are the units of resistivity then, in order to make it work out to ohms? Well, meter cancel one of this, so resistivity must be ohm meter, right? Okay, so resistivity must be ohm meter. So what is this thing called resistivity? Well, resistivity is a measure of how much the material that is conducting electricity, how much that material resists the flow of electrons. Okay, so if you look at a table in your book, there should be a certain place there where they give you the table of resistivity. And there is another constant called conductivity, which is, they use the Greek symbol sigma. Okay, and the conductivity is simply 1 divided by the resistivity. Okay, and the reason they did that is because they wanted to show the opposite relationship of a good conductor versus a good insulator. Okay, remember at the beginning, way when we were talking about insulators, we did a lab on that. We talked about insulators and we talked about conductors. We said an insulator is something that doesn't allow the flow of electrons. Conductor, a good conductor, is something that allows the flow of electrons. So a good conductor is a poor insulator, right? And a good insulator is a poor conductor. There's an opposite relationship. So this shows you that. Okay, if the resistivity is low, then the conductivity is high. So that's going to be a good conductor, poor insulator. Okay, good conductor, poor insulator. Of course, when I say good conductor, what does that mean? It's a relative term. You know, there's good, there's better, and then there's even better, you know. So, of course, that's a relative thing. The less the rho, the more the sigma. And the more the rho, the less the sigma. So that would be a material that has a high resistivity. It resists the flow of electrons. And the conductivity would be poor, so it would be that we could classify that as, let's say, a good insulator, but poor conductor. Okay. So let's look at that table in the book. Let's look at some of the materials. You know what? Let me go get the book just a second. Okay, let's see. It should be somewhere in chapter 27. Yeah, it tells us the resistivity, and there's another thing that we're going to learn is that the resistivity is temperature dependent. So we'll talk about that in a second. But the resistivity that they give us is the resistivity of the material at 20 degrees Celsius. You see? So this is at 20 Celsius. Okay, so what are some of the materials? Well, they give you silver, copper, gold, aluminum, tungsten, iron, platinum, lead. So the first set of ones that they're giving you are like the metals. Okay, so out of those, the smallest one is going to be silver, right? Out of the metals, the smallest resistivity is going to be silver. And so it's going to be 1.59 times 10 to the negative 8. Let's write this a little bigger. And then the biggest one would be lead, right? And then they give you, the next one they give you is nichrome, which is a nickel chromium alloy, commonly used in heating elements, like let's say in your thermos or whatever, some kind of heating element. This is 1.50 times 10 to the negative 6. Okay? So notice now this is 100-fold bigger than any of the other metals. Carbon 3.5 times 10 to the negative 5. Now they're getting, the numbers are getting bigger. 3.5 times 10 to the negative 5, that's carbon. And then we got germanium 0.46, silicon 2.3 times 10 to the third. And then on the bottom it says the resistivity of silicon is very sensitive to purity. The value can be changed by several orders of magnitude when it is doped with other atoms, okay, because it's a semiconducting material. So silicon is 10 to the third. Then you get to glass, 10 to the 10th to 10 to the 14th. Ten to the 10th to 10 to the 14th. Rubber, 10 to the 13th. Sulfur, 10 to the 15th. Fused quartz, 10 to the 16th. So the largest one there out of the list is 10 to the 16th. Quartz. Something of the order of 10 to the 6th. So out of this list, this would be the highest row, right? The biggest row. That means the conductivity is the smallest. So if we were to make a column here, sigma at 20 degrees Celsius, they don't give you the sigma, but all you would have to do is just reciprocate it, right? So this would be 10 to the 8th. What would be the units of sigma, by the way? Sigma is 1 over rho, so ohms to the power negative 1, meter to the power negative 1, right? So that would be that's pretty much it. Ohms, negative 1, meter, negative 1. So